Hello students, we all know that if we have two charges of magnitude q1 and q2, suppose that this charge is q1 and we have one more charge of magnitude q2. We are not talking about the sign of these charges, either positive or negative, and they are separated by a distance r. Then magnitude of force between them, if this setup of two charges are kept in either air or in vacuum, then force of attraction or repulsion depending on their nature will be, or we can say magnitude of force will be 1 by 4 pi epsilon naught q1 q2 divided by r square. But same thing if it is kept in some dielectric material, or we can say if distance between these two charges q1 and q2, this is q1 and another charge is q2, distance between these two charges q1 and q2 is filled with some material, distance is r, and this is filled with some material, means we have some material here whose dielectric constant is k. In that case, magnitude of force between them will become 1 by 4 pi epsilon naught multiplied by k, where k is the dielectric constant of this material, multiplied by q1 q2 divided by r square. Can we write this F is equal to 1 by 4 pi epsilon naught multiplied by q1 q2 divided by r into root under k whole square. Same thing, why I am writing this, you will know when we will solve one more problem. Like what I am trying to do here, suppose that not complete space but only half of or some part of space between these two charges are filled with some dielectric material, then what is going to happen, that we want to study. So here can we say that this distance r, or here r root k, is actually the effective distance between them. There is one normal distance, the straight line distance, or we can say geometrical distance between them, which will not depend on the material between these two charges, but we can say effective distance between these two charges or these two charges, which will also depend on the dielectric constant of this material, and that effective distance will be equal to root of dielectric constant multiplied by the geometrical distance. So r effective or d effective distance is equal to root under k multiplied by geometrical distance. Remember this equation, this will help you to solve problems. Effective distance between two charges is equal to root under dielectric constant multiplied by geometrical distance between them. Now the question is asking, if we have two charges, again same q1 and q2, q1 and q2, distance between them is r, but only a small part is filled with some dielectric constant, like this is some dielectric material whose dielectric constant is k, and total distance is r, and the part where dielectric material is filled is actually t. Now if I ask you what will be the magnitude of force between these two charges q1 and q2, what will your answer? So if we use the same theory again here, like what will be the effective distance there? See, this question looks a little complicated, but it's very simple. If we use this concept of effective distance, what will be effective distance? So we have to calculate the effective distance here. So total distance is r. You can see here for this distance, which is actually r minus t, effective distance is equal to geometrical distance. For first part, because here dielectric constant is 1 and root under 1 will be 1. So for this part, effective distance is also equal to geometrical distance. So we can write r effective, left part will be same, r minus t, effective distance is equal to geometrical distance. And when we will calculate effective distance for this right hand side part, this distance is t, but here we have a dielectric material of dielectric constant k. So this will become plus root under k multiplied by t, root under k multiplied by t. And now we can very easily write the magnitude of force between these two charges will be 1 by 4 pi epsilon naught product of the charges q1 into q2 divided by effective distance squared. So it will become r minus t plus root under k into t whole square. So remember like this, q1 q2 by effective distance squared, and effective distance is equal to square root of dielectric constant multiplied by distance, geometrical distance. So this will be the force of attraction or repulsion depending on their nature. If both charges are similar charges, then force will be repulsion. If they are opposite charges, this will be attractive forces, but magnitude of force is going to remain same. Now any question is asked, you can solve very easily. Like suppose that question asks half of the distance is filled by some dielectric. So very easily we can write F will become equal to 1 by 4 pi epsilon naught q1 q2 divided by r minus half plus root under k divided by half. So very easily we can solve these types of problem. Thank you for watching. Keep watching, keep learning. Thank you.